All right, so the second part of this factoring lesson, we're asked to solve 3x squared plus 17x equals negative 10. Sorry, my voice is really weird. I think it's because I'm not talking anymore. Anyway, our first step is that if we're going to talk about the zero product property, well, we need to have something that multiplies to equal 0. And right now, it equals negative 10, right? So I am going to put the opposite here on both sides here. And that way, I can factor this, okay? So now we have this trinomial equaling 0. So looking for the roots, right? I'm going to go through and find, well, what are the factors here? And remember our method, 3 times 10, 30. B is 17. Numbers that multiply to be 30 but add to be 17. Right? Okay, so now we could put this in our area model if we want. Okay, and put 3x squared here and 10 down here. And we know that we're splitting this along the diagonal, right? Okay, and then I could find, well, what are the factors, right? Or I could rewrite this and do this grouping method. Give me a second to get this just a little fatter so I don't look so kindergarten-like. So 3x squared plus 15x plus 2x plus 10. Right, and I'm going to group these two again, find, well, what is the greatest common factor here, and factor it out along the side. And I'm going to get, so that's one length. I'm going to assume it's the same length over here, right? Factor out, greatest common factor of a positive 2. And we're hoping this is x plus 5 if it works out right? So these two make up one side of the triangle. This makes up the other triangle. I don't know why I said that. Our area model for a rectangle. So 3x plus 2 is one of our factors. And x plus 5 is our second. And if you noticed, I did not write that it was equal to 0 up there on that line. I'll do it right here. And now we might go back to talk about the previous one where we were saying, hey, x minus the roots. You know, if I can find the roots just by factoring, why do I have to go through this solving process? Well, because here, whoops, we've got something in front now, right? We have a coefficient. So we can't say that one of the roots is negative 2. And we'll prove it here in just a minute, all right? Okay, so we're going to go, I'm going to move this up a little. Okay. And we're going to solve for 3x plus 2 equaling 0. And we're also going to solve that x plus 5 equals 0. Okay, I'll show all of this work, but 3x would equal negative 2. So here, x is going to be negative 2/3. Here, x is going to be negative 5. Do you see how neither of these, it just doesn't work? Now it worked here when I didn't have a coefficient, but it didn't work to just identify this as a root. Now when we have this coefficient here, you'll probably figure out a little shortcut to that, but I'm not going to tell you what it is here. I want you to figure that one out. And hopefully it comes in, to you more naturally. I don't want you to have one more thing to remember. So there's our roots, our solutions, okay? Okay, let's try a new example. Get this one out of the way. Do a little squiggle, maybe I'll do a different color here. So what is this, example 3? Solve. 3x squared equals 9x. How's that? All right, well, again, if we're going to use zero product property or we're going to solve a quadratic, we want it to equal 0. So I'm going to rewrite this by making it minus 9x equals 0. Okay, now factoring this. Something that I told you we would forget, and it should always be the first thing that we think of when we factor, is what is the greatest common factor, right? So if we put 3x squared here and minus 9x, what's our greatest common factor? 3x. And then we pulled out 3x, so it's x minus, sorry, totally messed this up. There we go. So 3x times x, 3x times, actually, did I mess it up? I'm having a senior moment, I'm sorry. Okay, I want you to go back to our thinking here of a times b equals 0, okay? So either a equals 0 or b, x minus 3 equals 0. And in our case, we know it's going to be both of these, right? Because it's going to cross this axis twice. Yes. Once at 0, once at 3. Okay, sorry for the little, I don't know what was going on in there, my little brain there. All right, we got a couple more examples because, you see these with different presentations, right? Actually, let's just do one more. I think we'll be fine with just one more. So, is this example 4? Is it example 4? Yeah. All right. This one's kind of a doozy. 12x squared plus 5. Oops, hold on. There we go. 5x squared minus 3 equals x minus 5. Wow. So again, our first step is that we've got to get this looking more like something that is factorable. And also, if we're solving, we want it to equal 0. Okay? So we need to, take both of these off the right side. And if we're going to do it to that right side, we also have to do it to the left side, right? So I'm doing these 2 simplification steps just to get this back into our standard form. So now it's 11x and 5x squared. And here, going to be a 2. And now we're at 0. But let's put it in standard form. Sorry, I missed that right here. 5x squared plus 11x plus 2 equals 0. All right, now we've got it set up so that we can go and do our work of factoring, right? Okay, numbers that multiplied be a times c, but add to be b. Hopefully pretty obvious there. Again, you could do your little box method, area method, or you could factor by grouping. The whole point was that this is split up along that diagonal, right? If we were doing our area model. Okay, so here, what's the greatest common factor? And then here, what's the greatest common factor? Just 1. We want these binomials to be the same, right? Because we want it to have the same width and the same length. So this is our width or length is 1, 5x plus 1, 1 factor. And x plus 2 is the other factor. So when we go for solving, a times b equals 0. A is 0, or b is 0, or both of them could be 0, right? X plus 2 equals 0. So if we go through and solve, I'm just going to jump down to the end here. -1/5 and -2. Now again, if, we're looking at this in factored form and thinking, well, I can pull out the roots. That only happens if we don't have a coefficient here. It's not -1, is it? Okay, we got some practice to do. I hope all this makes sense. If not, you know what to do. Make sure you contact me, okay?